Hello, welcome back. This is take 3 on part 2 of 6.1. So let's get after it. Try to be really careful here. When I look at this problem, I notice immediately, I can't help but notice, that the denominator is 0. So if I was to substitute in. So that tells me that the substitution method isn't appropriate. I have to do something else besides just substituting to find this limit. But it's really a lot of information if the numerator is 0 or not 0 on what I would do next. And so I want to know what the numerator is because that gives me information on what I would do next. And right now we haven't learned what to do if it wasn't 0. And so, but don't worry, that's coming. So this is the square root of the quantity 16 plus 9, which is 25. And then the square root of 25 is 5, and 5 take away 5 is 0. So it is 0. So this is indeterminate, which means I got to work harder. And the goal is to manipulate things so that in the denominator, x plus 4 will reduce out, will cancel out. Because that was making my denominator be 0, and I don't want my denominator to be 0. Okay, so I want to reduce that out. So because this is a binomial that involves a square root, you can multiply by the conjugate, and that will get rid of the square root. So I have here in the numerator x squared plus 9 minus 5, and in the denominator I have the x plus 4. And I'm going to multiply that by the conjugate. And what the conjugate looks like when you have a square root is it has the same first term, the square root of x squared plus 9, and it has the same last term, which is 5. So there's a binomial, but it's a plus here. Now why that works out so well, it just changing the signs, is that when I FOIL this together and I multiply this times this is the first, so a square root times a square root with the same radicand gives you just the radicand. So this right here is the first in my FOILing. When I multiply here to do the outer, I get plus 5 square roots of x squared plus 9. I'm not going to multiply this together ever again. I'm going to tell you, remember what happened last time, is what I'm going to tell you. Then when I multiply the inner, and then when I multiply the last, so 5 times 5 is 25. So see how that worked out, because 5 square roots of the thing minus 5 square roots of the thing, this is 0. And so what I'm going to tell you in the future, when we multiply by the conjugate, remember the outer and the inner are going to go away, and that's why you did this plus and this minus, so that you get one of them being positive and one of them being minus on the outer and the inner, and you wanted them to be the same, otherwise these terms wouldn't be able to go away. So that works out really well. Now what you do to the top, you got to do to the bottom. So I multiplied the top by the conjugate. So I have to multiply the bottom by the conjugate because this is a secret 1, right? This divided by this is 1. This binomial, exactly that binomial, so they reduce out to be 1. Now I don't physically want to FOIL the denominator together, because if I did, then I'd have to unfoil it, and that would be sort of chasing my tail. So I want to leave it multiplied together. The reason is, do you guys remember what our goal was? Our goal was to hopefully reduce out the x plus 4. So long story short, lost my limit here. I haven't found the limit, so I still should be writing the limit sign. So I'm going to write my limit sign here so I don't forget it. I haven't found the limit, so I should not be ignoring the limit sign. And I'm left with x squared plus 9 minus 25. So that's x squared minus 16 for the numerator. I haven't been able to reduce out the x plus 4, but now I'm getting there because all of a sudden, you know, a miracle has happened here, and this, if I factor the numerator, are going to have a common factor, right? So that's the next thing I'm going to do is whip out the F word, factoring. So that's a difference of squares, x plus 4, x minus 4. So where you work on a lot of factoring is in a pre-calculus class, and also in an intermediate algebra class, and also a beginning algebra class is where you would work on a lot of factoring. And if you need help with that, make sure you come and I'll help you with it, get you going on it, get you up to speed, remind you of it. Now here's the thing that we were hoping would happen, is that the x plus 4s would divide out. So x plus 4 divided by x plus 4 is 1. It's not 0, it's 1, right? And so now I have this, and now I'm on my way to being totally done here, because now all I have to do is do substitution here. So the part that was making it 0 over 0 looks like it reduced out. And so let's see what we get when we plug in now. We're going to get, for the numerator, negative 4, take away 4. And in the denominator, it is, parentheses are implied right there. So that's the denominator. And when I put in negative 4, I'm getting the square root of 25, which is 5. And 5 plus 5 is 10. Oh, yes, that's right. This is 10. And the numerator is negative 8. So this is negative 4/5 equals negative 4/5. So we did a lovely job on that one. We multiplied by the conjugate. So right there is the conjugate. Good. I think that's how you spell conjugate. I might have to look it up. Okay, so this is calculating using the limit laws with limits that involve absolute value. And so sometimes it's necessary, but not necessary on every problem, to rewrite it using the definition of absolute value. And so sometimes that's very, very helpful, is to rewrite it piecewise to find. And so, but if it's not necessary, I'm not gonna do that. Okay. So here, I don't have a denominator, right, that's going to make something undefined. And at 3, I got x's and t's in this problem. And so one of the two is a mistake. So this must be x, is what I was meaning. Otherwise, if it was t, so if not a typo, which I think it is a typo, and someone asks you to find the limit as t goes to 3, well, there's no t's here. So this would then be, as far as t is concerned, a constant. So this would be my answer, right? And so if this wasn't a typo, they haven't got any like that. So I'm sure that it was a typo on my part, and so that really should have been x, is what that should have been. And so there's no problems though. It's not undefined. The absolute value, it doesn't have domain issues like the square root has. So if I had the square root of, instead of having the absolute value, if I had the square root of x minus 3, then I would have to be careful about going to 3 and whatnot. But absolute value doesn't have that. X could be any value and would be fine. And so it could be a little above 3 and it'd be fine. It'd be a little below 3 and it would be fine. So it's okay to use substitution here. So this part's 0, and so 6 is our answer. Okay. But this one's the same as that one, even though this is a fraction, because when I'm getting near 3, there's no problem, right? The denominator is okay and the numerator is okay. So this is 3 minus 5 when I substitute, and this is 3 minus 5. This is an absolute value, so this is the absolute value of negative 2 over negative 2, which is 2 over negative 2, so this is equal to negative 1. Versus if I had this, and maybe I should have wrote it down this way. I don't know, but versus this. And so what I have to be careful, though, on this is that if I substitute in that x is 5, so on this one, I need to be a little bit careful. I'm going to draw my line here to keep this problem on that side over there. I have to compare because I know it is, it's 0 over 0, right? And so I'm going to look at, getting ahead of myself, since it's 0 over 0, I'm going to look at applying the definition here. And so just so that you know that the absolute value of x minus 5 over x minus 5 is equal to, so the only thing that's changing is the absolute value. And so this could be, keep it the same, let it be, I say. So this is x minus 5 over no absolute value in the denominator, so the denominator is just coming along for the ride, which is x minus 5. And this is when x minus 5 is greater than or equal to 0. I'm going to clean this up. And then the other time is the opposite of x minus 5, right? Over x minus 5, the denominator just came along for the ride. And this is when x minus 5 is greater than 0. And so just kind of cleaning this up just a little bit, this function that I had here, this function here, if I wanted to, I could have called it f of x, f at x, on the other side of the line there. I was trying to make it all fit, but it didn't. This function, though, that I just named, is either equal to 1, x minus 5 divided by x minus 5, or negative 1. And that is when or if x is greater than, if I add 5 to both sides, or equal to 5. And this is when x is less than 5. So now to find the limit of this piecewise defined function, I called it f of x, x goes to 5. This is just like the piecewise defined functions that we found the limit of a bit ago, right? And 5 is a boundary point. So when you look at the left limit, a little bit before 5, you get negative 1, positive 1. And when you look at the right limit, oh no, I was right on that. Sorry. When it's not left or right up here, I have to be really, really careful. So these numbers are actually smaller, and this is 1. So they're not equal to one another. So the limit for this function right here does not exist. Now, one thing I have to warn you is that when you're showing someone what a limit is, you want to make sure that you show your thought process and your work. There's other thought processes I could have used here, but you want to support your answer. And so just saying the answer is does not exist and going on to the next one without any explanation of why it does not exist or why the answer is 2 or whatever is not appropriate. So here, I'm going to check it out. When I put in negative 2 for x, it's fine. And so I'm not going to have any, and there's no issues with the absolute value. So this one I can use substitution on this. So I can just use direct substitution because I noticed that the numerator, the denominator is not 0, right? So if I plug this in, 2 minus the absolute value of negative 2, parentheses around it if you like, plus 1. So when the dust clears in the denominator, I have negative 1, positive 1. Gosh, I'm having trouble. I had some hives and had to take a Benadryl, and I'm going to blame the Benadryl on my trouble. 2 minus, and then the absolute value, that right there inside is the absolute value of negative 1 is what it is. And the absolute value of negative 1 is 1. So this is 2 minus, there's my minus, and then what did I have in here? 1. So this is 1 over 1, so this is 1. And I was able to use direct substitution on that. This one, on the other hand, not so much, right? I can't use direct substitution on it. So I have the choice of rewriting it using the limit laws. And so that would be okay, using the absolute value. So that would be okay. And that would be fair game to do. I am going to, and so anyway, so that would be the story. I want to show you another way of doing it if you wanted. So you could start off here and say that 2 minus the absolute value of x plus 1, this is a possibility, 3 plus x, is equal to, and then piecewise define, let it be, so 2 minus x plus 1 over 3 plus x. And then the other piece is 2 minus, and then it's negative of this. So it's 2 minus a negative x plus 1 over 3 plus x. And then you can do all your ifs, clean that up a bit and all of that.